It followed from the special theory of relativity that mass and energy are but different manifestations of the same thing, a somewhat unfamiliar conception for the average mind. Furthermore, the equation E is equal mc squared, in which energy is thought equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Cochran and Walton in 1932 experimentally.
Albert Einstein proposed an entirely new idea about how gravity works. According to this idea, massive objects, such as the sun, could bend space and time. This is similar to placing a heavy ball in the middle of a trampoline, causing it to sink. Even light could be affected by this bending and its path could change. If there really is a warp in space, why could this be something we cannot see with our eyes? But a way was needed to prove Einstein's idea. This is where another scientist, Arthur Eddington, came into play. Arthur Eddington wanted to test Einstein's theory using a solar eclipse. During a solar eclipse, the moon passes in front of the sun, blocking its bright light, which allows us to see stars that are normally hidden by the sun's brightness. Why did Eddington have to wait for a solar eclipse to conduct this test? Wouldn't it have been enough to just observe with a telescope? Eddington believed that if Einstein was right, the sun's gravity would bend the light coming from stars, causing those stars to appear in slightly different positions than usual. To test this, he organized 2 teams and sent them to different locations around the world to observe a solar eclipse. The results were astounding. Eddington saw that the stars had indeed shifted their positions, just as Einstein's theory predicted. This confirmed that Einstein's theory of general relativity was correct. Eddington used telescopes to make this significant discovery. Telescopes are like super-powered binoculars that allow us to see distant objects more clearly. Although the telescopes in Eddington's time were not as powerful as the ones we have today, they were still advanced enough to help him make this incredible discovery. Today, scientists use much more powerful telescopes. Thanks to these telescopes, they can observe galaxies millions of light years away, watch the birth and death of stars, and even find clues about the early moments of the universe. How much could we have discovered about the universe without telescopes? Do you think our ability to observe improves as technology advances? Or will some things always remain too far away to be discovered? Similar groundbreaking observations had been made in history. In 1610, Galileo discovered 4 moons orbiting Jupiter with his telescope. This discovery supported the idea that the Earth was not the center of the universe and led to a scientific revolution. In 1929, he discovered that galaxies were moving away, showing that the universe is expanding and supporting the Big Bang theory, and that the speed of this recession is directly proportional to the distance of the galaxy from us. This discovery showed that the universe is expanding and supported the Big Bang theory. The gravitational waves predicted by Einstein's general theory of relativity were first detected by LIGO detectors in 2015. This discovery marked the beginning of a new era in astrophysics and provided us with the opportunity to learn more about objects like black holes and neutron stars. When a scientific theory is accepted as true, do you think it is more exciting to discover that it is wrong one day or to continuously prove it right? Do you think finding the false is more valuable? At this point, it would be very appropriate to mention telescopes, which are wonderful tools we use to study the sky, similar to the telescopes Eddington used. Telescopes are like magical instruments that allow us to look deep into the universe. Through them, we can embark on a journey into the mysterious worlds of stars, planets, and galaxies. Let's take a look together at the world of telescopes. The story of telescopes begins in the early 17th century with a Dutch optician named Hans Lippershey, who invented an instrument to magnify distant objects. However, no one could have predicted that this simple device would revolutionize the world of astronomy. Telescopes allow us to see things that our ordinary eyes cannot. They help us explore the grandeur of distant galaxies, the birth of stars, and even the mysterious world of black holes. However, they do not all work the same way. There are different types of telescopes, each with its own capabilities. First, let's talk about optical telescopes, which are the most well-known type of telescope. These telescopes work by collecting visible light, just like a giant pair of binoculars. In other words, they use the same type of light that our eyes can see. This allows us to view planets, stars, and galaxies in their colorful forms. But there is not only visible light in the universe. Some telescopes are designed to capture radio waves. These radio telescopes can reveal mysterious objects that are not visible with regular light, such as cold gas clouds or pulsars. It's as if we are listening to the secrets that the universe whispers to us. There are also X-ray telescopes. These telescopes are used to observe the hottest and most energetic events in the universe, specifically objects that emit X-rays. We can watch events like black holes, neutron stars, and supernova explosions, which are like scenes from action movies of the universe thanks to these telescopes. Let's not forget infrared telescopes either. These telescopes collect infrared light, allowing us to observe cold stars, dust clouds, and even newly formed planets. They help us find baby stars and planets hidden under the blanket of the universe. What did it make you think that there are so many things in the universe that cannot be seen? All these different telescopes show us various aspects of the universe. Just like putting together pieces of a puzzle, each type of telescope helps us create a larger picture of the universe. And this picture becomes clearer every day, continuing to amaze us. Today, scientists use various tools such as ground-based giant telescopes, space telescopes, radio telescopes, and even detectors that detect gravitational waves to conduct observations. This allows us to reach previously unseen depths of the universe and make more precise measurements. For example, the James Webb Space Telescope. The James Webb Space Telescope, JWST, is one of the most advanced space telescopes ever built and is designed to explore the farthest and oldest corners of the universe. Launched into space in 2021, this telescope is known to have replaced the Hubble Space Telescope, but it is much more powerful. The Webb telescope can observe infrared light, allowing it to study how stars, galaxies, and other celestial bodies form, the early times of the universe, and even habitable planets. The greatest feature of the James Webb Space Telescope is its ability to capture infrared rays coming from the very distant corners of the universe. Infrared light is a type of light that is invisible to the naked eye, but is emitted by warm objects. The James Webb Telescope can observe the early times of the universe. What other mysteries do you think we could solve in the future? Is it possible to know everything, or will there always be unknowns? The Webb telescope features a sun shield the size of a tennis court and a very large gold-coated mirror. These mirrors are critical for collecting light from distant galaxies and obtaining very clear images. The telescope operates at an extremely cold point to block the heat from the Sun, Earth, and Moon, allowing it to detect infrared light more precisely. The James Webb Telescope not only helps us understand the beginning of the universe, but is also used to discover planets that orbit other stars and could potentially be habitable. In this way, it seeks to answer questions like, are there Earth-like planets? This telescope is set to make many significant astronomical discoveries in the future and will provide deep insights into the universe for the scientific community. The James Webb Space Telescope is a groundbreaking project that pushes the boundaries of science and makes a significant contribution to human history.